Substance X is a gas at room temperature. It is a simple molecular covalent substance. So here's some examples of simple substances. Simple substances are molecules which just don't have a massive sprawling structure like this down here, diamond down here. That's a big sprawling structure, or a giant ionic lattice like salts, sodium chloride, that is a giant structure. These are small, simple molecules. The molecules you can recall normally without too much scientific knowledge. Those are your simple molecules: water, carbon dioxide, oxygen. Which row of the table shows the properties that substance X is most likely to have? Simple substances are often gas or liquid at room temperature. If they are a solid like sugar, they melt very, very easily. So they have low melting and low boiling points. A lot of these often dissolve in water, like you can bubble carbon dioxide and oxygen into water. Sugar can dissolve in water, so they're normally soluble as well because they're very small, and they can be easily separated. They have weak intermolecular forces. So in other words, if you had another water molecule here, if I drew one here, it has a very weak force of attraction between another water molecule, or if I get a carbon dioxide molecule here, there'll be another very weak force of attraction between them. Because of this, they're very easy to separate with a bit of energy. We call these forces of attraction intermolecular forces. It's a really important word we use to describe simple molecules. And basically, because they have weak intermolecular forces, they have very low boiling points and melting points. So, and they're easily dissolved in water as well. So let's have a look. Boiling point, well, we want something very low, so that's very high, that's very high, so it's going to be one of these two. We know that the answer has to be one of these two. Then relative solubility in water, well, they'll probably be very soluble in water, so that's not going to be, so it has to be this one here, so C. Diamond has a giant covalent structure. State one property of diamond that is the result of its giant covalent structure. So it's only for 1 mark. You don't have to explain anything. You just have to state a property, a characteristic. So you can say it's hard because you can see every carbon atom here is sharing its 4 bonds, possible bonds, with other carbon atoms. So it's this really gridlock structure. It's very hard, one of the hardest substances on this planet. So you can say it's hard. Has a very high melting point because there's very strong electrostatic forces of attraction. Notice how I didn't say intermolecular, because these are forces between atoms, not molecules, and these are very strong forces of attraction. So we call these electrostatic forces, and they're very strong. And this is why things have a very high melting point, because they have strong electrostatic forces of attraction. Because of this, they're also insoluble. So, well, partly. This is also insoluble. These are atoms. Not to be confused with something like a giant ionic lattice, where you have ions, which also have a very strong electrostatic forces. If you remember giant ionic lattices, they look like this. They also have very strong forces of attraction, but because they contain charged ions, not atoms with no charge, like a covalent structure has atoms, these have ions. Because they have ions, they dissolve in water. Water is very good at dissolving ionic substances because of the charge. The water molecules can disrupt the charges. So anyone from hard, insoluble, high melting point will do.